The first slide, we're going to discuss about what exactly is cloud computing and what are the different workload patterns we have for cloud computing, and when compared to other computing techniques, how good basically this cloud computing is all about, and what are the different characteristics that made up this cloud actually. Whenever you say cloud computing, either it could be IaaS, PaaS, or Saas. So what makes itself call as a cloud actually? Like there are some characteristics actually, so we're going to discuss that. Okay. So going with the cloud, basic says cloud computing. Okay. So whichever is like we are actually develop. I mean anything which is connected to internet. Okay, like development and services. Just the picture shows, right? You have different data centers and it's all connected to internet, right? Wherever like you just log into your even if you say an example called Google Gmail, right? Gmail is actually based on cloud itself. Okay, so it's like even Chrome, the desktop application Chrome, right? It's been synchronized throughout wherever you log in, you get your bookmarks and other stuff, right? So it's like it's all connected to internet, right? Using your username and password, it's all secured. So everything you basically access through your browser, that is actually not everything. Okay, there are some websites as well, so not that, but basically some applications which are synchronized. So those actually based out of cloud. Okay, so there are resources geographically distributed over a large number of locations, say like a wide area network. So everything is connected through internet. All these data centers. So let's brief about cloud computing. So going into the next slide, we're going to discuss about what are the different load patterns, okay, workload patterns we have for cloud computing. So basically we have like 5 different workload patterns, starting from growing fast, on and off, predictable, unpredictable, connected applications. All right, we're going to go one by one. So when you say growing fast is a kind of pattern, okay, wherein basically it starts with very low resources, and the time goes on, actually they're going to increase their resources. So this is a kind of pattern where we have seen in the real time, say Facebook. Okay, Facebook initially they started their application just with an university. So once that got that got famous. So what they have done, they have actually expanded the business through cities, and then now it's millions of users are actually using it. Okay, for that what they have done is slowly they have increased the resources. The resources in the sense the number of servers, okay, or the load factor, okay, whatever. In order to maintain that load factor, they have increased the resources so that nobody would actually face that kind of surge. Like if there is any slowness in the application, right? The people will not be interested in looking into that application. So for that, to maintain that, they have increased the resources. That is something comes under growing fast pattern. And when it goes to the second one, that is on and off pattern. Okay, on and off pattern, wherein you won't need that resource all the time actually, like only at a particular point of time during a week or during a month. Say like a when you say like a payroll kind of application, right? So every 15 days, in some organizations, every 15 days you might need that payroll application, and the rest of the time you might not need it. And similarly, in some organizations, it's like a 1 month payroll cycle would be there. So what they would do is only during that point of time they would actually turn on those resources, okay, in order to access that application. I mean, make that application accessible, just to say, as I said, like payrolls is not used throughout the month or throughout the year. It's only at a particular point of time you would be using that, right? All the people will not be using it only at a single point of time when the pay slips or that when any incentives got released. Probably that point of time they would actually use it, right? So that point of time they actually increase the resources. So that's a crude example actually which I have taken. It's So similarly, it's like even in cloud computing, it's like pay as you go, right? So when you need that resource, you would actually pay for it. You won't actually pay for the whole month, only if you need it for a few days actually. So it's like per day as well. There are some applications wherein you can pay and you can use it. Okay. And when it goes to the third one, that is predictable and unpredictable. Okay. So basically, when you say predictable, so you would know at what point of time that particular resource is required and what point of time it doesn't require it. So that is actually called predictable. So in that case, if you take in any example, e-commerce sites, okay, where whenever there is an year-end sale or kind of things, which is almost predictable, right? They knew it, right? Basically, at that point of time, they might need some 800 times more than what they usually use it. So say like in the usual times they might need the 100% usage is there, or like say 50% usage is there. But during that festival season or like any kind of sale going on, probably at that point of time, the e-commerce sites actually hires more resources in order to maintain that site's business or something. Okay, that is predictable. When it goes to unpredictable, okay, say like you have a news site, okay, wherein I mean there is any breaking news or something, okay, you never know when the breaking news is going to come, right? So at that point of time, what they do is they immediately actually hire the resources instead of hiring it well and before planned, okay, like instead of hiring it on a planned way, they hire it within on the go actually, like whenever they have some kind of breaking news, or they knew it actually, like this breaking news going to last for another couple of days. That point of time, what they do is they hire more resources. It's like unpredictable. Still, they'll be able to manage it using cloud computing just by adding additional resources. So you need to pay extra for that if it is unpredictable. Similarly, when it takes connected applications, right? Connected applications is an one best, okay. Okay, the best example for connected application, like there are many examples. What I could say is there are many games actually nowadays wherein they're linked with your Google ID or your Facebook ID, right? So it's all connected. The applications are connected. I mean, you can take a couple of other applications in Google Chrome itself, wherein your ID is being shared throughout other applications as well. All the applications are actually connected using a single ID, right? So that comes under actually a connected apps. And commodity workloads, okay, unlike the above mentioned workloads, okay, whatever we have seen so far, there are some, I mean, which can be directly deployed using some solutions. It can be Amazon or Windows Azure or Google App Engine. There are some workloads, okay, which can be migrated through cloud platform, okay, that is email. Email is such kind of a workload which can be pushed, which is used throughout your year, or like you never know like when you want it, right? So that is another kind of workload. There are few applications similar to email as well, which are required. So what they do is they call them as a commodity workloads, okay, which are used. It's like throughout the 365 days they use it actually, okay. It's not like one particular time they use it, or it's going to increase the usage or something. They give a standard usage for emails, okay. So it cannot even exceed, or it even if it is less also, it doesn't matter actually. Those kind of unpriority things actually they come under commodity workloads, okay. So when compared to other computing techniques, okay, when you take any organization for 50 users, okay, just have a simple comparison over here. What happens in traditional computing and what happens in basic cloud technique, okay. So the business operational considerations, okay, they want when it goes to traditional computing techniques, they have to buy or upgrade new servers, okay. When it comes to cloud, okay, it's all like you just need not worry about the upgradations. The upgradations happens on the go, like you will not even know actually, like they go offline updates and there are online updates as well in terms of cloud computing, Okay, so servers you need to maintain in traditional, and when it goes to cloud, it will be maintained by the vendor itself. Like whoever is a vendor, who that person actually maintains the servers. And the labor or the people who look after the servers or setup or installation is required in general computing, that is traditional computing, wherein this setting up the for setting up these servers or installations is not, I mean, in cloud it's not required until unless you own your own private cloud at your site. Okay, only then you require this setup. Otherwise, if you're just buying the license, then it is not required as well. Okay, even you need not worry about the network or the backup system, or if you take any email backup or any antivirus or anti-spam. These things are all not included because everything is included in the cloud itself. So the rest of the things actually, when you consider traditional computing, so you need to buy each and everything actually, and in order to upgrade things as well, like it will be very difficult. Like if there is any new version, say if there is any new version in the market, that point of time you need to either upgrade your systems if it is not matching the requirements, or you need to again buy new licenses for that. Okay, but it comes to cloud, right? Only thing is that if there is any additional resource in the sense any additional person is going to use it, you have to buy an additional license. Okay, you're not going to pay for whole the software you're going to use it. Only the time you're using it, you're going to pay for that. It's like pay as you go, kind of a prepaid thing. Like you just pay for certain amount of time, and you don't need the service, you just discard. I mean, you don't pay it further. That's what the whole intention is all about. Okay, and these are some 5 different characteristics of cloud. I mean, if they satisfy all these 5 characteristics, only then we can term it as a cloud. So first one is on-demand service. Then comes a broad network access, resource pooling, rapid elasticity, and measured service. When it comes to on-demand service, right, the name itself says on-demand service, like you need it anywhere and anytime, like for 365 days you need the service, so it is available basically. So just through your browser, your username and password, you will be able to log into your cloud. So all you have to, the only disadvantage is you need to have internet connection, right? Without internet, then it's not possible to log into your cloud. So that is on-demand service. So when it goes to the broad network access, okay. So broad network access is accessible from any device, okay. Either it is right from, I mean, you need to have the bandwidth, okay, like bandwidth to access the cloud. So it can be accessible through any device, like say you can access through your desktop from your laptops, or you can even access it through your mobile devices like tablets, okay, or even mobile phones. You'll be able to access it. Okay, all you need is just the internet connection, and this particular characteristic gets satisfied through that. And when it says resource pooling, okay, resource pooling is something like where a multi-tenant architecture comes in picture. Okay, it's like shared resources through the cloud users. Okay, when it says shared resources, I would say like a crude example, like I can take an apartment, okay, say like you're staying in an apartment wherein it's been divided into, it's equally divided, okay. In that point of time, there are some common resources to be used, like a parking or some water, electricity, okay. Say like you would not be able to use the whole, like for example, you are getting some 100, say like 100 units of some power or something, okay, you'll not be able to use the whole thing, only a part of it will be able to use it. That's like a limitation to your apartment itself. Okay, similarly in cloud as well, when it comes to resource pooling, as I said, like multi-tenant architecture, what it does is actually it shares the resources equally throughout the cloud users, which will ensure that, okay, which will ensure that the other users are not affected by your excessive usage. Okay, like you might have got excessive usage, say like But still, there are some solutions as well for if you want to use excessively, you need to buy more space or something. Okay, that's a different story. But still, in a general terminology, what happens is you would be restricted with some kind of limitations. Say like you'll not be able to run this many SQL queries, or you'll not be able to run the batch this many times or something. There are some limitations actually, like when it goes to cloud. Unlike traditional computing, wherein you can add up your own servers and build up your own hardware. So when it comes to cloud, okay, cloud ensures that everyone will have the same level of access, so that the other people are not affected who are using it. Okay, and when it comes to rapid elasticity is something like you can very well, the name itself says, like you can easily expand your business just by adding more resources. Okay, so you, for example, for today you have some 10 users currently working in an organization for say like any cloud technology, say Salesforce, and tomorrow there are some 10 more actually added up, and you need additional license actually. So you need not actually worry about the number of PCs actually, or the number of servers actually to be increased. Okay, it's not required. So only thing is like 10 more additional licenses can be bought, and they can straight away start working actually. That's what the rapid elasticity is. It's like you pay for the additional 10 resources, or and you can start using it. That's it. You need not pay for the whole the network or the hardware, whatever is being used. So nothing. Only the thing is you have to pay for the additional user itself. That's it. The rest of the things are already in place. So, and when it comes to the last characteristic, that is measured service. Okay, when I say measured service, okay, without measuring this whole thing, like how a person would be able to bill. Like for example, I am the vendor and I would like to bill you in that case. So how would I actually measure the service? So for that, actually, the cloud itself will have a characteristic, wherein whenever you log into the cloud, okay, automatically it will have the through which IP you have logged in, and what resources you are currently accessing it, and how long you have accessed it. So based on that statistics, actually, they would measure the amount of your usage, okay, and then they would actually bill based on that, okay. Or if you have already paid for it, okay, there is a pay as you go, as I said, right? So for example, you paid some $100 and you have used only some $40. How would that get calculated? Okay, based on your usage, the times you have logged in, and the number of resources you have used, based on that, actually they get calculated, and the rest of $60 will be available for your usage. Okay, once the $60 is done, probably you would get a notification like your current access has been probably you have to upgrade, or you have to buy. That kind of notification you might get. Okay, that's it about characteristics. Okay, going on to the different types of clouds. Okay, there are different types of clouds available. Apart from this public, private, and hybrid, you have another one that is community cloud. Okay, or they would rarely use it. Okay, I have never seen what exactly this community cloud does basically. But when it goes to public and private, these are more often used. Okay, these are different types of clouds. Okay, deployment method actually is a public deployment or a private deployment. Okay, or sometimes it can be a mixture of public and private. They call it as a hybrid. Okay, so public is actually offset. It's all third-party management, wherein you would not know actually what type of infrastructure is being used, and what type of network service and other stuff. Only thing you're worried about is your username and password, and you have to log in through your. It is actually accessible externally. Okay, to external in the sense anywhere you'll be able to access it. But when it comes to private, it's only meant for a company internal usage. Okay, private clouds are very, they use it just for if there are any highly sensitive data available on the cloud. Okay, in that point of time, they actually build their own private cloud, so to ensure that our data is not exposed to some some other malpractice or something. Okay, so what they do is they actually on site, they'll actually maintain their own infrastructure on site, that is in their own company, and offsite. Generally, there are two ways actually. On-site is available, off-site is available. On-site is something like within your company, and off-site is which is beyond your company. Okay, like outside your company, they call it as a private. Okay, so when it goes to hybrid, okay, mixture of private and public becomes a hybrid. So there are some applications wherein which can be shared between private and public as well, like say email application in a company. Okay, you can even maintain that public. Okay, though you have a private cloud built through which you're sharing this email application to public. Public in the sense you'll be able to access it even at your home as well. Okay, there are some applications which are very sensitive, like banking information or transaction information within the company, like financial information. At that point of time, what they do is those applications are only meant within the company. Okay, they say like intranet. Okay, you can say like they are only accessible through intranet within a particular IP range. Okay. So that actually speaks about the private cloud. Okay, so mixture of both, they actually build up. I mean, based on your own requirement. Okay, you can have your deployment happening. Like if you need a private cloud, you can build your own private. The only headache with the private cloud is you have to maintain your own infrastructure. Okay, along with the network and other stuff. So, but when it goes to public cloud, you can actually, you need not worry about this infrastructure. Okay, somebody would maintain it and you just use the service. Okay, and some people actually, they even I mean, if they have excessive storage or something, they even some part of the private actually they can be exposed to public as well. I mean, this is very secure thing, and only in terms of security. Okay, if the people are worried about, they actually chose private, but public is equally secured. Okay, apart from banking information, people are not ready to expose it through public. That is the only reason. Otherwise, even public is very secure. Okay. So this is what, I mean, you have different, as I said, like we have different types of models in clouds, right? IaaS, PaaS, and SaaS. Okay. So when you have anything on-premise, that is the one which speaks here, right? On-premise is something like on your side, you're trying to maintain it using some traditional computing. Okay, right from the applications till the networking thing, all the other underlying layers are there, right? These layers are actually maintained by your company itself. Okay, so everything is being managed by yourself, right? Right from the networking, storage, servers, till the application part, everything is managed by yourself. But when it goes to infrastructure as a service, okay, some part is actually maintained by the vendor who is actually providing the service, and some part is maintained by yourself. Okay, the thing which is maintained by the major part is the networking till virtualization is being maintained by your vendor. Okay, so and the rest of the from operating system till application end. Okay, that point of thing will be maintained by yourself. The example would be say like you got a license from Citrix or VMware or something. Okay, so what they do is VMware, you need not worry about the networking, storage, servers, and virtualization. They will actually give you a virtual user ID and other stuff. So they'll give a link for which you have to log in. Okay, and from which the operating system, you can choose your operating system. Okay, based on that the operating system gets loaded. Okay, you say like you have to tell the vendor based on which he would actually load it, but still it is managed by yourself. Along with this runtime, middleware, and data. So what data you want to store it on your applications, and everything will be managed by you. And application development also can be done by yourself. Okay, when it goes to infrastructure as a service. Okay, so similarly, when it goes to PaaS, that is platform as a service. Okay, along with infrastructure, you have the platform, that is operating system, middleware, and runtime as well. So all you are worried about is the data and the application. Okay, the best example is the force.com, that is a Salesforce. comes under this PAS. Okay, that is this is a platform actually. There are two things as we're going to speak about. One is force.com. Another one is salesforce.com. Okay, in the next couple of slides we're going to speak about that. And force.com comes under this PAS, that is platform as a service. Okay, so wherein you build your own applications on the platform along with the data. Okay, data is something which you enter into the application, right? So that is also managed by you. When it goes to software as a service, software as a service is something which is already built in. Okay, everything is built in, and you're just gonna log in and use the service. That's it. It's just for, it is built in for a purpose, and you're gonna log in for that particular purpose, and you can utilize that service. That's it. So for that which you're gonna pay for the license. That's it. So say like Salesforce.com is actually a SaaS application which is built on force.com. Okay, so it's actually built-in application, sales application given by Salesforce itself. So anyways, we're going to speak in the next couple of slides. Okay, and these are the brief examples actually. So what are things fall under which part actually? When it comes to infrastructure, we have different vendors like Rackspace, HP Cloud Services, Amazon Web Services. Okay, similarly when it goes to platform as a service, that is PaaS, we have force.com and Windows Azure. Okay, you can trial usage. I mean, force.com, you can have a free developer account. When it similarly for Windows Azure, you get a free account, but you need to pay $1 actually. Okay, for 1 year usage, probably you can pay $1, and you can start using this Windows Azure platform as well for building your applications. Similarly, when it goes to software as a service, so these are all built-in applications, right? Gmail and so Salesforce.com and SAP. Okay, everything is built in, wherein you just want to use that application, install it in your systems, or through your web you can access these applications and start using it. Okay, it's nothing. You'll not be able to change how the Google is like. For example, Google Mail is already built in, right? So what you're trying to do is just using the application for sending emails or receiving emails. So you'll not be able to change the way it looks, right? It's all maintained by Google itself, right? So that's it about say cloud computing. Okay. When it goes to the next slide, that is we're going to introduce you to Salesforce. Basically, this was formed in '99 by a former Oracle executive, that is Mark Benioff, along with his friend Harris, and other two friends actually, Dave and Frank. Okay, so basically Dave and Frank come from another company called Clarify. Okay, they built Clarify is another automation software which is used in many of the call centers earlier actually. Back in '90s they were using it. Even now Clarify is available, but still to very limited customers. So what they have done, they have actually built this initial sales application, and later on from 2005 onwards, actually they started grabbing this. They started building different applications by say like data.com, or say Chatter is another application. You have data.com or site.com. There are different applications actually available in Salesforce. Every year actually, year on year actually it got increased, and now it is like very powerful now. Even now we I would say like currently it's #1 in as per Forbes, I guess it's #4 in terms of revenue and other stuff. So in terms of employee satisfaction, it's #1. That's what I heard in some time back in news. And going to the next slide, which actually tells you what are the different clouds available in Salesforce. Say right from the Sales Cloud, Service Cloud, Database.com, Data.com, Chatter, Force.com, and Social Enterprise. These are different clouds are currently available for Salesforce. Okay. When it comes to Sales Cloud, okay, you will have all the sales related applications in Sales Cloud. Okay, when you log into say force.com account for using your developer account, using your developer license, You would be able to see all of these in one platform, but basically they are actually distributed through different clouds like Sales, Service, Database, Data.com, Chatter, and Force.com. Force.com, as I said, is a platform. Okay, this is also actually a cloud which offers that service. Okay, and this is the first it's the first multi-tenant architecture CRM application which is built completely on cloud, and you're going to develop everything over the cloud. Okay. And going to the next slide. Okay, as I said, there is two difference, that is a Force.com and Salesforce.com. Salesforce.com is a built-in application, okay, on Salesforce. On Force.com platform. Okay, so it's a built-in application which is ready to use, and which is actually built on Force.com, which is a platform as a service, right? So here, all you have to worry about is, see, the application exchange, a user interface, a logic, or the integration, or the database, or the infrastructure. Everything you're going to use it as a service in Force.com platform, right? So even the development is actually is part of service. Okay, you're not actually buying the whole infrastructure or the database or integration services, nothing. So only thing is you just buy the license for this Force.com, and you can start building your applications. Okay, so all you have to worry about is just when it comes to other techniques, probably you need to worry about all these infrastructure applications and operation services. But whereas in Force.com, that is a platform as a service, which is offering you which is offering you a platform to develop whatever applications you would like to. Okay, so wherein you're not worried about this infrastructure, application services, or any operating services. Okay. This is the same thing actually, that is it lets you just focus on the applications what you're trying to build, rather than what type of software or infrastructure that is being used to run them. Okay. Here is an example actually. What they're trying to tell is, as I said, like global infrastructure as a service, how many transactions. Okay, this is a data center actually. You can look into this data center, wherein how many million transactions are happening and what is the average speed of each transaction. And this is a very, this is not updated basically. If you want to know the current transaction details and everything, okay, you have something called okay, trust.salesforce.com. Okay, when you go to the bottom, okay, it tells you what are the number of transactions each day actually. The current days from that day actually till the last 1 month data, you would be able to see it, how many transactions have went through, and what is the average speed actually, which is in seconds. Okay, so it's almost like some million transactions going on a daily basis. Okay, some days it's more and some days it's a bit less. So you will be able to see the average speed of each transaction happening. So this is one website which is completely transparent to everyone, and it lets you know what are the different transactions going on, and the ones you see here, right? These are the green tick marks over here. These are different instances available. So each time you log in, okay, like say these are North American instances, and Asia Pacific is this. Okay, you can just expand it. You get to see 3 Asia Pacific. Depending upon the location you are logged in, that particular instance gets activated. Like when you log into your developer account, you will see that instance. Okay, in your URL itself, you will be able to see it. Similarly, Europe and the Middle East. Okay, you have some around 5 different instances. Okay, and sandboxes, you have some different, I mean, these are common sandbox instances, okay, which are available irrespective of the location, I guess. So sometimes you would see around 20, I guess, you would be having some sandbox instances, okay. I mean, there's just some audit data, okay, it's nothing to do with your actual development, it's just an audit data wherein you, if you want to look into like how exactly it's currently performing or like how many transactions or what's the average speed of each transaction, probably you can just log into this site and you can check it out. And going to the next slide, as I said, it's a multi-tenant global scalable architecture, okay. Each time, okay, each instance basically is actually having the database cluster, app servers, fully mirrored DR facility. DR is a disaster recovery facility, and you got to add new pods for scalability. Pod is nothing but a particular instance, we call it as a pod. Okay, so it is very scalable, as I said in the earlier slides as well. So rapid elasticity is one such characteristic of a cloud which actually tends to scalability, wherein as the additional resource or additional persons or any additional location needs an access, probably they'll start a new pod structure, okay, which has got all these database clusters and app servers involved in it. Okay, all you see is an instance which is given to you, wherein you just log into that instance. This we have already seen it, that is transparency, wherein trust.salesforce.com it just tells you like at what time the instance is on and what time the currently maintenance is going on, and if there is any issues also. You would not face any discrepancy. Like for example, if any instance is currently not doing well or there's any maintenance going on, automatically the other instances will be actually activated for your login. Okay, so. And similarly for security, okay, you have different types of securities available. That is the first two things, okay, CIS certified and Saas 70 type 2. Okay, these are two different certifications type wherein Salesforce has undergone. Okay, which actually tells you like it's very much secured. Okay, you can just Google it out what exactly Saas 70 type 2 and CIS Trust certified is all about. And network and physical security. This is also important characteristic, like wherein the whole network is actually secured and you will not be able to, I mean, no intruders will be able to access this network until unless they are certified to access, okay, or they have valid access to it. Okay. Similarly, you have IP restrictions and single sign-on and identity confirmation. Okay, IP restrictions is nothing but when you log into your Salesforce, okay, and as an administrator, you can actually restrict your users in order to access only a certain amount. Like you have some list of IP addresses or a range of IP addresses wherein your company works in. So you can give the range of IP address only in that range. Probably you will be able to log into your Salesforce account, and the rest of the IP address, like you're trying to log in from your home, it's not possible. Okay, because it's been restricted using an IP address access option. Similarly, you got your flexible single sign-on options, which has to be configured by the administrator. Okay. Single sign-on is nothing but a best example is your Google itself. Okay, you try to log into your Google, automatically the Google Mail or Google Drive, or that's a kind of a single sign-on. You need not log in every time you search. I mean, you log into its own, like even in your company, probably once you log into your company's site, and there are some related applications as well. So they can actually configure it as a single sign-on, wherein you need not every time you just access that application, you need not log in. So it's like a single sign-on, and you will be able to access all the applications. And when it comes to identity confirmation, like it's very secured. Okay, as I said earlier, whenever you're trying to log in from a new IP address or new IP range, or from a new computer, okay, automatically you would get a notification like please enter the security code. similar to how we do it in banking transactions. When you're trying to access it from the same computer, first time it would ask for entering that code or a one-time password or something. When you're trying to do it from a different computer, definitely it'll ask you for the identity confirmation, right? So it's a kind of a feature available, right? And when it goes to database, okay, Salesforce has got its own database, similar to how we have SQL and Oracle, SQL Server and Oracle. Okay, you have a database inbuilt wherein you will be able to create any table, any field, any relationship, just using your user interface, and also some kind of programming if you are interested. There is using programming as well. You can actually create. You can insert records and other stuff. Creating table definitely needs UI access. Okay, user interface. They're just telling you, like in this slide, how many transactions per SQL. This is not required anyways. Just giving for brief understanding. Okay, how many schema edits and transactions per second is happening. Okay. And integrations, okay, integrations it's also, you need not install any services or any infrastructure in order to do integration. Okay, all you can do is you just use a web services, REST or SOAP APIs in order to integrate with Salesforce. Okay, that's what they're saying. Like integration also can be done using a service. And when it goes to workflows as a service, okay. Workflows is something like, okay, it's like a business task or something. Okay, say you have a particular task, say like leave approval has to be done. Okay, in that case, what you do is you just go to the leave portal and you apply for a leave. And that once you apply for the leave, your supervisor would get intimated, right? And then he would actually reject it or approve it. Once it is done, again back to your screen, it says your leave is approved or rejected. Okay, so it's like kind of a flow, right? So this flow can be done either programmatically using some triggers, or it can be using a declarative way. That is, you can start, just point and click. That is called a declarative. Like using Salesforce, you have point and click functionality wherein you will be able to use it and do it declaratively. Okay, so you can do approvals, time-based, formula-based, or some kind of outbound message you can send. Okay, using workflows. And similarly, as we talked about this declarative logic, so it's like just point and click. Okay, and you just select it. You need to just you're not building this actually. You're just trying to select the options and using that. So that is declarative. And when it's formula based, you just write a formula for that particular logic. Okay, in order to, similar to how we write formulas in Excel and other applications, so we write formulas as well in Salesforce to validate the data or do some kind of validation. Okay, when it goes to procedural logic, okay, we write some triggers in order to validate the data. Okay, so that is about procedural logics. Okay, this slide basically speaks about how exactly this code looks like. It's a Java-like syntax. You have a transactional kind of things happen. It is transactional. That code is Apex. Apex is an inbuilt in-house technology by Salesforce. Okay, which looks like Java and Java-like syntax, and it's strongly typed kind of language, and it's transactional. You got something says governed is nothing but it's governor rules. It's like kind of limitations we're talking about, right? In multi-tenant architecture, as I said. So governed is nothing but it's just limitations on a cloud. So all these things can be done through a service. It's not like you can have it off the service, that is in Eclipse as well. You can write the code and deploy it on the cloud. That is also possible. And building an interface can be done. Okay, for the code we have Apex, right? APEX. For building a user interface, you have something called Visual Force. Okay, this is similar to HTML we have this is a markup language from Salesforce. Okay, so you can build any interface using this Visual Force. You can add the other technologies like CSS, HTML5 also can be merged with this Visual Force, and you can make the pages even look better. Okay, rather it's just a basic markup language, which is more powerful than the HTML, because you got a lot of tags which are inbuilt, okay, which does the work for you instead of again writing from scratch. This slide basically tells you like how the user experience would be like when you're trying to integrate two different things. One is from SAP and other from Salesforce, and there's an auto management tool which has been built, how it has been done through REST or SOAP. Okay, till here we discussed about different features available, and next slide actually tells you what is the pricing per user per month licensing. Actually, different licenses we have, right? So we have contract manager license, group manager, you have professional, enterprise, and unlimited. Along with this, you have one more license, that is developer license, so which is free of cost. Okay, so each user $5 per month is contract manager. It's $25 per month per user is group. Similarly for professional, it is $65. Okay, just for information, anyways, need not worry about these things. This comes under Sales Cloud and Service Cloud. More or like Sales and Service have got a similar application. Apart from contract manager and group are not available in Service Cloud. Some differences are there. And going on to the certifications, okay, these are different certifications available currently. So as an administrator, you have administrator as well as advanced administrator. Okay. Similarly for implementation, you have consultant and Sales Cloud consultant and Service Cloud consultant, which are related to this administrator as well. Okay. So once an administrator certification is done, you can actually go for a Sales Cloud and as well as Service Cloud. So, and this is advanced, which is like once these three are done, probably if you are interested, you can go for the advanced. For developer, you have only two certifications, that is Dev 401, we say is as Salesforce developer, and advanced developer, that is Dev 501. Okay. And you have also architect, technical architect, which is more advanced than what we see here in advanced developer. So there's a certification logos which are currently, there's a new logo actually which is updated last year for each certification, right from developer to the administrator, advanced administrator, and you have Sales Cloud and Service Cloud. Okay. So in order to register for this Salesforce.com, okay, each one is all like around, I guess, is $200, right? So and every year we got to mint for maintenance exams as well. Like there are three types of releases available in Salesforce. One is winter release, summer release, and spring release. Okay, every year you have these three releases happening. Currently, spring 15 is going to release in a few days, and winter 15 is currently going on. And this is a website for registering for a certification exam. You can register it and write the exam in any Prometric center, or you can write it at home as well by just having your webcam and directions given in a website. Okay, so they would actually tell you at what angle the webcam has to be kept. Because it's like it's being monitored from Salesforce itself. Okay, somebody is actually, it's automated one which is monitored from the, even if you're trying to move around, probably the exam gets stopped automatically. So you have to register yourself. Once you got completed this training, probably you can just register and you can apply for exam. Okay. And for practicing purpose, Salesforce itself, they have actually developed two applications. One is recruiting application, another one is warehouse application. So it's completely based on administration. Okay, it's just point and click declarative type of application that I have built. It's nothing, no coding is involved in this recruiting application or either in warehouse application. So there are PDFs available. Probably I can share with you once we start going. Okay. And this is the way you can actually create your own Salesforce developer account. You just need to go to developer.force.com. You have an option to sign up. Okay, when you click on sign up, you get to see a screen something like this. Okay, you have to just give your details and just click on sign up. Okay. So this is how you can get started with your developer account, free developer account, and you can log into it and start building your applications on cloud using Salesforce. Okay. And that's pretty much what I thought discussing today. Probably if somebody has got any doubts,